So good morning, everyone. Today we'll start with the new point, that is different coordinate systems. Okay, so in this coordinate systems, first we'll see what is need of these coordinate systems, means why we are using these coordinate systems, what are the types of coordinate systems, and then we'll see one by one three coordinate systems in detail. Okay, so here the coordinate systems why we need. Okay, all of you may know that when we are using the two-dimensional systems, then that time we are using the x and y coordinates, right? And when we are using the three-dimensional systems, that time we are using x, y, and z coordinates. But these coordinates are coming under one coordinate system. Okay, so that is called the Cartesian coordinate system. So there are such different coordinate systems which are used to represent any vector. So why we need this coordinate system? So these coordinate systems are required to represent or to describe any vector accurately and to express vector in terms of its components. Okay, components means suppose we are considering any vector a b bar. Okay, that time and when we are putting that vector in a space, that time we should know what are the coordinates, means what is the length of that vector from the x coordinate, from y coordinate, and from z coordinate. So there are different means if we are considering it in a Cartesian coordinate system. But when we are considering in another coordinate system, that time also we can find its different components. Okay, so it is necessary to have a reference directions. So we should know or to represent that vector, to describe that vector, reference directions are necessary, means particular directions are necessary. We are using x, y, and z axis. So for that there is a particular direction. Okay, we are not representing that directions in or that vectors in any direction. They have a particular direction. So if we consider any point or any vector in a space, that time we can represent that vector or any point from by taking these three directions as a reference. Okay, so such directions are represented in terms of the coordinate system. That's why we are using the different coordinate systems here. Now, all of you understood why we are using the coordinate systems? Why we are using the coordinate systems? So, if we are considering any vector or any point, that time uh, to represent that vector, okay, means different components of that vector, we need particular directions. Okay, we need particular directions. That's why these directions are represented by using these coordinate systems. That's why we are using these coordinate systems here. Okay, now there are different types of these coordinate systems. The three coordinate systems are here. That is, first is the Cartesian coordinate system, or it is also called rectangular coordinate system. Okay, because this Cartesian coordinate system, we can take a rectangle as a reference there. Okay, so here it is also called rectangular coordinate system. Then second is the cylindrical coordinate system. Okay, cylindrical coordinate system means here you have to imagine one cylinder. Okay, one cylinder there, and accordingly how the coordinates are changing. Okay, means what are the directions, how we can consider its directions, and what are the points we'll see in that point, that is in cylindrical coordinate system. And third is the spherical coordinate system. Spherical means you should consider here one sphere. Sphere means you can consider here one ball. Okay, so if you consider a ball, and in that if any vector is placed, then how the directions can be taken. Okay, and there are some angles. So how these are represented, how it is varying. So it will be seen in this spherical coordinate system. So all of you understood there are three coordinate systems: Cartesian or rectangular, then second is cylindrical coordinate system, and third is the spherical coordinate system. So this is very basic and very important. That's why today's lecture is very important, as I'm telling from last lecture. Okay, so this is your basic, and it will be applied in all chapters. So you should know all the coordinates, how it is represented, what are the differential lengths, how the different planes are given, what are the differential areas. You should know there. Therefore, everyone concentrates for this lecture. This lecture is very, very important. Okay, because if you don't understand how to represent any vector in different or today we'll see the Cartesian coordinate system, you will not understand the other points also. Okay, so here first we'll see the Cartesian coordinate system, and everyone note this different types of coordinate systems. Then uh, what is the need of coordinate system? And now we'll see the Cartesian, or it is also called rectangular coordinate system. Okay, so here this is a rectangular or Cartesian coordinate system, the first coordinate system. Okay, now all of you know we are considering here the three axes, that is x, y, and z. Okay, x, y, and z. Now tell me, what is the angle between x and y axis? What is the angle between x, y axis? Yes. X axis, right? Then y, and this vertical is z. So what is angle between x and y axis?
120.
120 degree. Okay, anyone else?
9.
Huh?
90 degree.
90 degree. Okay. Others? Aishwarya? Yes. Renuka? What is angle between x and y axis? Okay. So here, when we are considering as a two-dimensional system, that time what happens? We are considering this as one circle. Okay, you may have studied in basic electrical also, or in power system. There is a phase sequence, right? So in phase sequence, the angle between any two phases is equal to 120 degree. That is different. But here we are using a three-dimensional system. Okay. Therefore, the angle between this x and y axis is equal to 90 degree. But how it is? How it is? Then angle between y and z axis is also 90 degree, and angle between z and x axis is also 90 degree. Then how it is and how to imagine this? Because this is purely imaginary. Okay, this is purely imaginary, because if you consider this as a whole, then surely this the total angle is 360 degree, and when you divide into 3, the angle between any two axes should be 120 degree, but here I am saying the angle is 90 degree. How it is? So here, wherever you are, if you are at home, then just simply consider the corner of your room. Consider corner of your room. Okay. So wherever you are, suppose you are at the corner. Okay. Then at the floor and at a corner, there are, this is your origin. Okay. This is your origin. At the floor where the three lines are there. Okay. So this will be your origin. Okay. Then the line to the left side. Okay. Line to the left side means your left side wall and your floor. Okay. In between that, there is a line. That is your x-axis. Okay. Is it your x-axis? Right? Consider a corner at your home. Okay. Any corner of your room. Then consider a left side. The floor and the left wall. The floor and left wall is making the x-axis here. Okay. Then your floor. This is your floor. Okay. In between this x and y axis, this is your floor. Okay. This is your floor. Then your y axis is your wall. This wall and this floor. In between that, it is making your y axis. And there is one vertical line. Okay. One line, that is the corner of your room is showing this vertical z-axis. Okay. समजलंय का? Yes or no?
Yes, madam.
Okay. Once again, I will tell you. So for this three-dimensional system, consider corner at your home. Okay. एक corner consider करा. त्याच्यामध्ये 3 ऍक्सिस आपल्याला शो करायचे. ओके. सो त्या कॉर्नर फ्लोर जो आहे, फ्लोरच्या सेंटर, कॉर्नरचा जो सेंटर आहे, ओके, त्याच्या वन साइडला जाणारी जी ऍक्सिस आहे, ओके, वन साइड जी आहे लेफ्ट साइड तुमची, दॅट इज युअर एक्स ऍक्सिस. फ्लोर वरती दुसरी एक लाईन आहे, दॅट इज युअर वाय ऍक्सिस. आणि व्हर्टिकल जे आहे दॅट इज युअर z-axis. Now tell me what is angle between x and y-axis by imagining your corner only. What is angle between x and y-axis?
90 degree.
90 degree. Then angle between y and z-axis? Angle between y and z-axis? 90. And angle between z and x-axis?
90.
90 degree. So these angles, all angles are only 90 degree, means all three axes are at right angle. Okay. Now here we have to show the different planes. Okay. Different planes, and this is your origin here. Here the origin is shown. Okay, here the origin is shown. Now, when we are considering this x and y plane, okay, when we are considering the x and y plane, that time, what is the value of z quantity?
0.
What is the 0? Why it is 0? Why it is 0? Slide is not changed. Change.
दोन्ही पण एकाच पॉइंटला ना. स्वतःनी 0.
Yes. What? Hello? I'm saying or you are saying as this is written here only? This is Z is equal to 0 because here we are considering X and Y plane. And here there is a origin, right? Here it is origin. Means its coordinates are 0, 0, 0, right? 0, 0, 0. When you are going in X direction, the length is increasing. Length is increasing. Suppose I am considering here 0.5. Okay, here 0.5, right? So means at this point, the length is 5. Similarly, here also I consider the 5. Okay, but what I'm asking in X and Y plane, what is value of 0? So when I'm considering X and Y plane only, means you should consider your floor only. Okay, your floor is your X and Y plane. Okay, therefore, in that X, Y plane, your Z is equal to 0 because here this X and Y plane is nothing but the floor and the Z coordinate is equal to 0 there. Okay. Therefore, this is also called Z is equal to 0 plane. Okay. This is called Z is equal to 0 plane, or it is also called XY plane. Okay. It is also called XY plane. Okay. Okay. Now, similarly, when we consider Y and Z plane, okay, when we consider Y and Z plane, means your wall, consider your wall between the Y axis and Z axis. That time, your Y point will be present and Z point will also be present there. Okay, but the X coordinate, there X will be equal to 0. Okay, X will be equal to 0. So it is called X is equal to 0 plane, or it is also called YZ plane. Okay, it is also called YZ plane. Okay, similarly, when you are considering the Z axis and X axis, means the left side of your corner, that time X axis is there or left side wall, and Z axis is also there. There, this Y is equal to 0, or it is also called XZ or ZX plane. Okay, ZX plane. Okay, so all of you understood? So in Cartesian coordinate system, we are using the coordinates X, Y, and Z here. X, Y, and Z. And these are represented like this, and the angle between any two axes is equal to 90 degree. Okay, and when we are considering any two axes, okay, any two axes or any plane, that time, so when we are considering the XY plane, the third plane, that is third coordinate, Z is equal to 0 there. Okay, so समझ रहे हैं? Yes or no? Yes or no? Kajal? समझले का नहीं? Audible? Yes, okay. Okay. Now, in this only, we'll see the left-handed system and right-handed system. Okay. Now, when we are considering this Cartesian coordinate system, this can be represented in two ways. Okay, means there are two types. That is, first is the right-handed system and second is the left-handed system. Okay, so here in this right-handed system, you can see the right-handed system. There, the x, y, and z coordinates are shown. Okay, and we are rotating in the anti-clockwise direction. Okay, we are going in the anti-clockwise direction. Means if we are considering any screw, okay, if we are considering any screw, and when we remove that screw, that time how we are moving? We are moving in the anti-clockwise direction. That is, the movement of that screw is in upward direction. Therefore, that is called the right-handed system. Okay, remember, this is called the right-handed system, and second is the left-handed system. So in left-handed system, this is x direction, y and z, and we are going in clockwise direction. So when we are going in clockwise direction, that time, so again consider a screw, and when we are going in clockwise direction, uh, uh, the direction of the screw is in downward. Okay, in downward direction, and it is called the left-handed system. Okay, it is called the left-handed system. Okay, so these are the two systems, but in whole electromagnetic engineering, we are using this right-handed system. Okay, that is x, y, and z coordinates. Okay, and this is the rectangle. How actually we are representing, and why it is called the rectangular coordinate system. Okay, so in this way, you can only draw the x, y, and z coordinates. Just don't try to draw the rectangle. Only draw the x, y, and z coordinates and write down right-handed system and left-handed system. You can represent only vectors and direction. Hello. So what? Okay. Now we'll see how actually this vector is represented. Now here we are considering a Cartesian coordinate system. So when we are considering any vector a bar, we can represent that vector in x, y, and z coordinates. So we have already seen that this vector a bar is equal to a bar ax, a bar x. This is the unit vector x, a bar x, a y, a bar y, and a z, a bar z here. Okay. Now here we have to represent the different planes. Okay, because we are finding the lengths from origin to the to that axis. Okay, therefore we'll first see here how these planes are located. Okay, planes are located, means x is equal to constant, y is equal to constant, and z is equal to constant. Okay, so here we'll first see the x is equal to constant plane. Okay, so here for that purpose, and everyone draw this fastly, very fastly. Okay, so this is your x, y, and z axis. Okay, and this is your origin. Okay, now here uh, here this is shown that how actually this x is equal to constant plane is shown. Means what? When we are finding any point, okay, on x-axis, okay, on x-axis, that time we are finding the length from origin to that point. Okay, so when we are considering this, okay, that is x is equal to constant plane, that time uh, this is your horizontal line. Okay, means it is showing the y-axis. This is your vertical line, means it is showing your z-axis. Okay, so it is called the x and z plane. Sorry, y and z plane. Okay, so it is called the y and z plane. When your x is equal to constant, your plane will be yz plane. Okay, your plane will be yz plane when this x is equal to constant. समजलंय का हे? जे सपोज 0 असेल तर ठीक आहे. YZ प्लेन कधी असेल? Y and Z प्लेन or we can YZ plane means it is only for the representation. Okay, this is for the representation. When we are considering that x is equal to 0, that plane will be YZ plane. But here, when we are considering x as any constant value, that time which values will be present? Means here y and z values will be present here. Okay, y and z values will be present. Means this plane is showing you this the y is equal to constant. Okay, when we are considering y is equal to constant, that time again you have to draw a plane which is perpendicular to y axis. Okay, we have to draw a plane which is perpendicular to the y axis. So this is your x, y, and z. Okay, and this is your origin. And everyone draw the diagrams neatly because I'm taking on PPT. That's why this pointer, by using pointer, I cannot draw a exact diagram, but you draw correctly. Okay. Now, so from this y is equal to constant, just tell me what is this upper line? Which axis this upper line is showing? Upper and lower line.
X.
X, correct. So this is your x-axis, and these two vertical lines are showing.
Z.
These two vertical lines are showing z-axis. Correct. Okay. Means when your y and y is equal to constant, because we are considering a plane which is placed which is placed where the y-axis is perpendicular. Okay, where the y-axis is perpendicular, and here it is showing some point from the origin. Okay, that is, you can consider the 5, 6 up to so on. Okay, so that is showing some point, and when it is placed, so this is your x, and this is representing your x and z coordinates. Okay, x and z coordinates are present there. Okay, now the third, that is z is equal to constant. Okay, so when your z is equal to constant, x, y, and z. Okay, so when this z is equal to constant, that time, now tell me, what this line is showing? These two lines are showing which axis?
X.
Which axis? This x.
X,
X. Then next, Priyanka,
Y,
y. These two axes, these two lines are showing what?
Axis.
Darkened lines. Panchashila. Akshay. Akshay Tele.
yes ma'am.
Yes. These darkened lines are showing which axis? X, Y, and Z. Yes. Suraj. So it is very necessary to understand these coordinate systems and imagine, because this is imaginary only. Yes. This is in direction of which axis? This line is in direction of which axis?
X-axis.
X-axis. Correct. Okay. Therefore, it is showing the x-axis. Okay. This is also x. And these horizontal lines? Horizontal
Y-axis.
lines
Y-axis.
in direction of y-axis. Correct. So, means when you are considering z is equal to constant plane, okay, z is equal to constant plane, that time your x and y coordinates will be present there. Okay, x and y coordinates will be present. Okay, so everyone note this, draw these diagrams. Then we'll see the next point in the coordinate system and draw it correctly. Hello. Completed?
Yes, ma'am.
Okay. Now we'll see the next point. So here, one more point I'll add. That it will be easy for considering the differential length. Okay. So here, if I'm considering the differential, that is the small part, okay, small part or a small section, that time we are considering dx, dy and dz, okay. So when we are considering the differential lengths or differential areas, you have to simply represent this as dy, dz, okay, like this. Then if it is x and z, then it will be dx, dz. Okay. And similarly here dx and dy. Okay. This is when you are considering the differential lengths. Okay. Now the next point here. So when we are considering the Cartesian coordinate system, we are representing any we can represent any vector in the x, y and z direction, okay, in x, y and z direction. So for that purpose, again consider a rectangle, okay, consider a rectangle where where a point P is located. Okay, suppose point P is located somewhere here. Okay, at the corner. Yeah, I'll draw first. Okay, suppose there is one just like this, one rectangle is there. Okay, then at this corner, okay, at this corner, suppose one point is located. Okay, that is point P. Okay, and this point P is having coordinates x, y, and z. Okay, x, y, and z. Then suppose point P dash is located somewhere here, suppose. And this is point P dash. Okay. Now, at this point P is having x, y, and z coordinates. So, when we are considering this vector, that is P to P dash. Okay, when we are considering the vector P to P dash and P is having x, y, z coordinates, then when we are going from point P to point P dash, its length is increased, right? Its length is increased when we are considering any vector from 0 to point A, 0 to point A. So when we are going from point 0 to point A, its length is increasing. Similarly, when we are going from point P to point P dash, its length is also increased. So it is represented as, means the coordinates of this vector point P dash are x plus dx. Okay, means we are considering that there is a small change in the length. Okay, small change in the length. So it is x plus dx. Okay, in x direction, it is increased by dx. Therefore, the total length in x direction is x plus dx. Similarly, what will be the length in y direction? What will be the length in y direction? Yes.
Y plus Y dy.
Yes, correct. It is y plus dy. Okay, y plus dy. And what is in z direction? It is z plus dz, right? It is z plus dz. So these are the coordinates of your point P dash. Okay, these are the coordinates for point P dash. Now, just tell me what will be vector PP dash. Vector PP dash. So it is again end point minus start point. So find this end point minus start point. So when we are considering the vector PP dash, it is the P dash minus P, right? So it is x plus dx minus x into unit vector a bar x, right? So just tell me the final answer. X plus dx minus x into a bar x. So it is can you find or not? Okay, so it is dx, the first point, p dash minus p, x plus dx minus x. So it is plus dx into unit vector a bar x plus it is dy a bar y plus dz a bar z. Is it right? Dz a bar z. Okay. So you simply take this p dash minus p. Okay. Then over then we'll see the differential length. Okay. So this is nothing but the dl bar, that is the differential length in vector form. Okay, it is nothing but the differential length in vector form, that is small dl bar. Okay. So when we are considering this rectangle or a volume, that time we have seen all planes. Okay, when we are considering this x-axis, y-axis, and z-axis, we have seen all planes here already. So when we are considering the plane which is perpendicular to the x-axis only, means this plane. Okay, so what is present here? What is present here? Which axes are present? Y and Z axis, right? means this is dy and dz. Means what is the differential area? What is the differential area for this? Okay, so if we consider this only, so just tell me what is the differential area here when we are considering x is equal to constant. This is your for finding the differential area. So when x is equal to constant, what will be the differential area for this? Yes. How we are finding area? Simply length into width here, right? So it will be what is present here? Y and Z are present. Therefore, the differential area is dy dz, right? The differential area is dy dz for x is equal to constant. Similarly, when y is equal to constant, what is the differential area? What is the differential area when y is equal to constant?
dx dz.
Yes, dx dz, correct. Dx dz. Then when z is equal to constant, what is differential area ds?
dx dy.
Dx dy. Dx dy. Okay. हे समजले? Note this. Note this. Means there only you note. Then I'm going to give you summary also. Don't worry. That's why I explain these three planes, all three planes differently. Okay. Because when we are taking a combined diagram, then you cannot understand that. And note it correctly. Don't make any mistake. Okay. So here you can see this front side. This is your which plane? X is equal to constant. This is showing x is equal to constant and the differential area for this is dy and dz. Dy dz. Similarly, when you consider this line, okay, this second one, which is perpendicular to y-axis. Okay, this is y is equal to constant plane. Here, your x and z axis are present. Means your differential area is here dx and dz. Okay, dx and dz. Similarly, this line, this plane, is showing the z is equal to constant plane. Z is equal to constant means x and y are present. Therefore, it is the differential surface is here dx dy. Dx dy. Okay. Now we'll see the summary of all this. Okay. Means whatever things you learn here, that is the summary of Cartesian coordinate system. Okay. So in Cartesian coordinate system, we can represent any point. We can represent any point by using three coordinates. Which are those? X, Y, and Z coordinates. Okay. Then second is the unit vectors. Okay, unit vectors. So here, when we are considering these x, y, and z coordinates, okay, this is x, y, and z coordinates. Now, the unit vector in direction of x is represented as a bar x. Unit vector in direction of y is represented as a bar y, and unit vector in direction of z is a bar z. Okay, so here the unit vectors are are a bar x, a bar y, and a bar z, and a bar z. Then the differential length. Differential length. These are dx in x direction, then dy in y direction, and dz in z direction. Okay. Then we have seen the differential area. Okay. We have seen the differential areas. So when x is equal to constant, then what is the differential area? What is the differential area when x is equal to constant? Dy into dz. When x is equal to constant. Then when y is equal to constant, it is equal to dx into dz. Dx into dz. And when z is equal to constant, it is equal to dy, sorry, dx dy. It is equal to dx dy. Okay. Then the differential volume, here it is given. All the differential elements are given here. So when we are using this differential surface area as a scalar quantity, we can write like this. But when we are considering as a ds bar, that is a vector quantity, then you have to multiply here by unit vector. Okay, by unit vector. And the total volume, okay, total volume of this rectangle or of this of this element is given as dV. The differential volume is given as dV is equal to dx, dy, and dz. And this volume is a scalar quantity. Okay. And this volume is a scalar quantity. Okay. So all of you noted these points. In next lecture, we'll see the cylindrical coordinate system. Okay. So now we are having meeting. So for today, we'll stop here. Thank you all and have a nice day. Thank you.